is Alejandro, and welcome back for day 115 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's bonus for November 8th, 2024, and let's get straight into it. Okay, today we get a LeetCode medium problem 1829, maximum XOR for each query. You're given a sorted array nums of n non-negative integers, and an integer maximum bit, okay? You want to perform the following query n times. You find a non-negative integer k less than 2 to the power of maximum bit, okay, such that, nums of 0, my eye, sorry. Find a non-negative integer k less than 2 to the power of maximum bit such that nums of 0 XOR nums of 1 XOR up to nums at length minus 1 XOR k is maximized. K is the answer to the ith query. Okay. Wouldn't you want to just XOR with 1, 1, 1, 1, 1, 1? Okay. Remove the last element from the current array nums. Return an array answer where answer of I is answer to the ith query. Okay. Remove the last element from the current array nums. Okay. Okay, so you perform a query n times, and each time it's going to be okay. And every single time you're going to remove the last number. Which really means, okay, what that means is like you can XOR all the results together, and every single time that you result, you can XOR the last number in nums, so that essentially it undoes the number, right? Because if you have like, you know, n1 XOR n2 ... XOR n underscore n. Geez, my eye. I don't know what's going on with my eye. You know, num2, num1. Then if you XOR this with, you know, num n, then this becomes, you know, 0 itself, which means that it doesn't affect the rest of the thing. So that's already fine, right? So here we can do XOR properties. You know, first of all is like x XOR 0 is equal to x, right? Here we have, you know, x XOR x is equal to 0, right? The ones, wait, is it like this? Yeah, right, because if you 1 and 1 become 0, 0, 0 become 0, and 1 and 0 become 1, yeah. And so everything will be the same bit, therefore it'll all become 0, right? Yeah, like x XOR y is equal to the same as y XOR x, right? So it's like these are some basic XOR properties, right? So if we, you know, take the XOR is equal to 0, right? For num and nums, XOR will do XOR equal to num, right? And okay, I think I already have an idea of how to do this. Find a non-negative integer this. Okay, so first of all, I want to do something, right? If I have a maximum bit, so here, okay, let's look at an example. Maximum bit is 2. Python 3, we have max bit, we'll say is equal to 2. If I do, how does bit shift work? Can I do, is it 1 bit shift of 2? Right. Which is 2. So let's say my max bit is equal to 5, right? I want 2 to the power 5, which is 32. If I do 1 shift of 5, that gives me 132, right? Okay, and then, so I can do that very, very efficiently. So max k is equal to 1 bit shifted by maximum bit. Okay, so that's for sure. I could essentially do this minus 1, right? Now, okay. If we want to take our current XOR, right? We want to maximize XOR with XOR and k, right? Which means that ideally, right? That means that ideally we what? We XOR with the inverse. So it's like 1 and 0 stays as 1s, and then 0 1s become 1s, right? So essentially, so want k to be inverse in bits of XOR. XOR being this variable, okay. We want it to be the inverse in bits of XOR, right? Because the point is, like, if XOR is equal to, you know, like 1, 1, 0, let's do this and so on, then what we want is for k to be equal to the opposite, right? So here we want it to be a 0, a 0, a 0, a 1, 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 a 0, 1, a 0, a 1, a 0, a 1, a 0. That way, when we take the XOR, right, if I just do this, right, then this becomes, okay, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right, when I XOR them all, right? So that's essentially the nice idea here, right? So ideally k is the inverse. It's just that k must be smaller than this, right? So essentially all the leading bits will have to be zeros, and then the remaining everything else can be the inverse of XOR, right? Now the only thing is, like, how do we do this efficiently, right? Do I just get through all the bits and essentially, so like, you know, I go through all the bits, of which there's up to maximum bit many, right? Okay, so essentially I'll do for I in range, we'll do the last number in nums, right? So length of nums minus 1. Then we'll go up to -1 non-inclusive, so up to 0 inclusive, and backwards, because we want to keep deleting the last number, right? So here, best k is equal to, you know, 0 times maximum bit, right? Because everything else must be trailing zeros. Okay. We want to take the bin of XOR, right? So this is a number. So here we want to take bin of XOR, and we want to take the last negative maximum bit characters, right? So if I do bin of this number, right, I want, let's say we have this, and I want the last 5 characters. Do I do -5 and onwards? Does that give me 5? 1, 2, 3, 4, 5. Okay, I can do that. So this will be negative maximum bit and onwards. And then for these, I want to inverse them, right? So here we'll do string dot join 1 if c equals 0, else 0 for c in this many. Yeah, so okay, for now it's just memory inefficient. But yeah. Okay, so this is a thing, right? And if I do something like, you know, int of this guy, base 2, yeah, this is fine. So I can do int of this guy with a base of 2. I know this is a lot of code, but bear with me. I will make sure that things are okay. And yeah, and now we can do answer.append k, where our answer is over here. And here we will do return answer. Delete last number in nums. So here we'll do XOR, and we'll XOR it equal with nums of I. Right, okay. But now, yeah. Okay, so first of all, does something like this work? No. XOR. So at the beginning it's 3. Well, unless no, it's not that I have it in reverse order. Okay, interesting. So yeah, so here the queries are as follows. First query, nums is equal to this, k is equal to 0. Since 0 XOR 1 XOR 1 XOR 3, XOR 0 is equal to 3. So yeah, let's take a look. What is 0 XOR 1 XOR 1 XOR 3? It's this. Bin of 3. 1 and 1. So here I say I want the opposites, right? So why is my k equal to that? Print XOR. So I have 3, right? Maximum bit is equal to, say, like 2. What if the maximum bit is bigger than the actual number itself? Then there's problems, right? Okay. We'll figure this out. Now XOR is equal to 3. Yeah, so this is 0. So my first answer is 0. Okay, that's very, very good. Then I get rid of the 3, right? Wait, k is equal to 3. Wait, our k... Yeah, wait. Yeah, so 0. XOR 3. Yeah, our XOR is 0 now. XOR equal to 3. Now let's do the same thing. So now we get 1. Well, we should be getting 3. Bin of XOR. Maximum bit. I think I know the issue. Yeah, bin of XOR from negative maximum bit onwards. Yeah, so I'm doing B0. How the heck does it even understand what this means? This you can actually convert? No. Oh. Otherwise 0. Yeah. One if c equals 0, else 0 if c equals 1, else this. Let's see if this works out first of all. Just janky little hack. But no, not really. Still the same issue really. But yeah, we can't just be doing, otherwise, DSA, right? And then it's just like, that doesn't mean anything. Yeah. Okay. So I need to go. Yeah, I want a negative maximum bit index, right? I want the last that many. So the length, bin XOR is equal to bin of XOR. I want from 2 onwards. Right. I want the last that many characters. But then if there's not that many, then I'll start from index 2. Length is equal to length of bin XOR minus 2. If I want negative 5, I can do 1, 2, 3, and I can do negative 3, right? But I can't do negative 4. If maximum bit greater than length, start index less than or equal to length, do this and this. Else let's just do something like this. Does something like this work for now? L0, L0. Still wrong, eh? Maximum bit is less than or equal to length. Really now? Okay, the point is like if I have yeah, maximum bit is 2, but I have a 0, I want to make it a 1, right? Oh, is it not 1? I want it to be 3. Okay, I gotta pad. Okay, I gotta add some padding basically. Okay. I gotta add padding. If anything, we can go back to here. If anything, I can do something like this for now. Yeah, but I might still fail in the cases where negative maximum bit is actually too large. So okay, let's try to submit this. So I might still fail in such cases. Yeah, I'm still gonna fail in such cases. If start index is equal to negative maximum bit, if maximum bit less than or equal to length of bin of XOR minus 2, else 2. Okay, let's try that for now. We might as well add this test case in here. Yeah, this is not going to work. And this might still not work. Again, I just have to think really carefully about how I'm going to do this. Okay. Run. Right. Okay, so the negative maximum bit if it's in bounds, right? Yeah, no, this is still not going to work. Yeah, well, it's still not in bounds. I want to say, yeah, and the point that I do 1 is because if I'm going to do padding, the reason I do 1 as my default case is if I want to do a bunch of padding with zeros, well, then I know what is the opposite of zeros that I want. It's going to be 1s, which is why it's like a good thing to default with 1s. If anything, we might as well solve the problem by not having that inverse thing, just so that we make sure that we're being very, very careful as we do this. Right? Negative maximum bit. There we go. Yeah, so the point is that these things might not be long enough. Yeah, so we want to do maximum bit operations, right? But what if our thing is not long enough? Then we want to do some paddings, right? Here we can do, 0 times maximum bit plus this, right? And this won't work, but if I default to 1, 0, 1, 1, this might work. It doesn't. Whoa, 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 whoa. Duck. Yeah, so this technically works. Yeah, and this will pass all the test cases. It's just definitely not efficient, right? Yeah, of course. Okay, so this definitely works, but again, it's just very, very inefficient. But okay, there we go. You know, bada bing, bada boom. So we're like, you know, on the right track. We know how to solve the problem. So that's very cool, at least. But yeah, okay. Okay. We've got to think about a better way to do this. The reason why this works is that even if I have like, you know, the 0b, doesn't matter, the b, whatever, and so on. I just set a default value of 1. So like, what I really want is a padding of zeros, right? And each of them, I want an inverse number, so it's going to be a 1, right? So it doesn't matter what I pad with, right? I could pad with like, you know, G for Google, let's say, and like that'll still work, right? That's not the problem at all here. But now we gotta think about how to do this a bit more efficiently. Okay. So yeah, this is a good comment. So I'll just add what? Okay, I'm gonna take this, Control X. There we go. Okay. Okay. Now, okay, how do we do this efficiently? Right? We might always be XORing the results, so we'll just always get the last few, however many. But yeah, this is definitely just not efficient. Although, okay, yeah, wow. We're in the 600s, but people are down over here in the 80 ms. But yeah, okay, okay. Before we judge, you know, let's make sure that we get this. We also have like some printings in here, just like, you know, why do that? Yeah, okay, we just save on 200 ms just by doing that. So it's like, yeah, there's a lot of optimizations we can make here. Here we don't even need to do this. Here we definitely don't need to do this, right? Okay. let's think, right? So I want to flip all the bits, basically. I want to flip all the bits. Is there a good bit flip operation? I want to convert 1 to 0. XOR doesn't do that, AND doesn't do that, OR doesn't do that. Something that converts, you know, 1 into 0, 0 into 1, like a NOT operation. Can I do NOT of a number? Not 1. Not 1. Oh no, that's complement, right? So not -2. Okay, wait, not 1. Bin of 1. Bin of -2. Interesting. Not of 1, 2, 3. Bin of -1, 2, 4. Bin of 1, 2, 3. Yeah, it's just 2's complement in here or something like that, right? Plus 1 and inverse, yeah, okay. That's not doing what I think it does. Right. Although does it? 0 became 1, 0 became 1, 1 became 0. But the point is that it added 1 or something, right? These don't get changed the way that I want them to get changed. I wish I knew if there was a bit flipping operation. One, 2, 3 minus 1. Bit -1, 2, 5. Okay. 0b 1, 2, 3, 4, 1. Comma 2 into this guy, yeah. Four minus 1. plus 1. Yeah, it's just not gonna work. Yeah, so bit flipping, not the most convenient, not the most convenient at all. All right, so we'll say bin XOR is equal to this. Is equal to bin of XOR. K is equal to string.join. Two things. First of all, it'll be a padding of zeros, which will pad as 1 because we want them to be opposite. So here we'll put padding as a comment. Times how many, right? Length of bin XOR minus 2, right? And we want maximum bit, right? We want negative maximum bit. If the length is 3 and our maximum bit is 5, it'll be 5 minus this thing, right? Something like this, right? As well as this for I in range maximum bit, right? So the beginning will be minus 0. So here will be bin XOR of length bin XOR minus 1 minus I. Okay, so let's try something like this. Jeez. Okay, maybe we need to wrap this as an array. Okay, maybe we do this plus this. Geez. Length of, jeez, okay. What is this? Okay. Maybe we do int, base 2 of this. Yeah, geez, okay. This is not good at all. Okay, so for I in range, maximum bit. No. XOR minus 2. This, I'm going to take the max of 0, comma that. If I do that right, this times 0, that is the empty string, good. Plus string.join, we shall do you know, k plus or equal to this dot join XOR of index is equal to 1, 0 for index in range, length minus maximum bit, comma length. This will be the length. Yeah, okay. My bad. Come on. So this will be max 2, comma this. Alright, come on. Come on. Come on. +1 or something. Yeah, okay. Why is this logic so annoying? Yeah, with the padding it's obviously very easy, right? The point is I care a lot, like very deeply. Okay, like num to take is equal to you know, the minimum between maximum bit and length, right? We'll say, okay, first of all, padding length is equal to max between 0 as well as, you know, maximum bit is how many bits we want minus num to take. K is equal to 1 times padding length plus string.join if equals 1 else 1 for cn bin XOR from negative num to take onwards, right? Here we'll say k is equal to int of k comma 2. Oh, come on. This is length. Okay. Okay, so that works. Okay, so that's one thing that works already, right off the bat. And it doesn't make us any faster. Okay. Okay, so this padding length, whoa. That's doesn't need to be a string, right? We can bit shift. Right? Whatever the length of this is, minus num to take. Minus num to take. Right. Let's get rid of this. Sort of append this guy. K is equal to int of bin k, comma this too, right? And here we'll say k. So here we'll say this is equal to bin k. loop invariant, delete last number nums. Okay, cool. Get XOR all numbers and nums. This fits in here. There we go. Okay. Now this logic, right? We need to find a way to make this logic work just a lot better. Is there a way, right? Like, convert a 1 into a 0 and a 0 into a 1. It would be like 1 minus that, right? Yeah, I can't really think of a way to do that efficiently. Padding length, yeah. This we could probably do more efficiently though, where it's like, okay, right, like if I take int of 11111, that's 7, shift on 2, bin of 28. Yeah, 1111, yeah. Then k, right, first of all, okay, k is equal to int base 2 of times padding length wait. Shifted by num to take, right? Okay. Then we take this guy, base 2, and maybe we do k plus or equal to this. Base 2. Length greater than 0, else 0. Okay, so that does work. But is it more efficient is the question. Nah, it just makes things even worse. I mean, it's a cool trick, but yeah, it just makes things even worse. This is an annoying step. Flipping all those bits. Yeah, you might as well take, you might as well concatenate them. Right? It'll just be like this plus this guy. K is equal to that, right? Yeah, so that just happens to be better. That's a rip. That's a rip. That's a rip. Okay. String dot join that guy. And now this one we can even make it the other way, right? So we can make the zeros. And that's not a problem, right? Yeah, so that's not a problem now. But we might as well make it the default of 1. There we go. And here k we can do is equal to int of this base colon 2. Yeah, 787. Yeah. Okay, no worries. Otherwise, you know, it's fine if this is our final solution. You know, we tried seeing if there's a way to make this a bit more efficient, but I don't know if I can find one right now off the top of my head. But you know what? Otherwise, as always, in all my videos, I do a quick recap of how I was able to solve the problem. So for this one, essentially, it was actually kind of clever. It's the very, very first idea that came into my mind. I just had it stuck in my mind, so I wanted to, you know, just implement it and straight off the bat before I forget what I'm thinking of, instead of like, explaining it all throughout. So essentially here it's like, okay, you're given a sorted, oh, I didn't even realize that it was a sorted array of nums. Wait, is that part of how we can make this solution efficient? Okay, I did not even read that. Okay, you're given a sorted array, but I didn't realize it was a sorted array. Okay, maybe there's a more efficient way to do that because of that. Nums of n negative integers and an integer maximum bit. You want to perform the following query n times, right? So find a non-negative integer k is less than 2 to the maximum bit, such that nums of 0 XOR nums of 1 all the way up to XOR nums of up to the last number. XOR of k is maximized, right? K is the answer to the ith query. Remove the last element from the current array of nums, and then return answer where answer of I is the query here, right? So the very first thing to realize is like, okay, you want a non-negative integer k such that this is less than 2 to the maximum bit, right? Well, let's say maximum bit here is equal to, let's say 25, right? Well, what's 2 to the power of 25? It's this. But this is just the same as taking number 1 and bit shifting it 25 slots, right? It gives us the exact same number. So in order to make things efficient, here what I do at the very beginning is, well, actually I remove that line of code. Oh yeah, because I do the padding stuff instead. Okay, no worries, sorry, okay. Ignore that part. But essentially, okay. So we want to maximize this value, right? So moving on from here, we realize that at the end of each query, we're going to remove the last element from nums. Well, let's revisit our XOR properties, right? If I take anything x and y, right? X XORed with 0 is just x. If I XOR x with x, that becomes 0. And XOR of x and y is the same as the XOR of y and x, right? So these are kind of the XOR properties that we get to play with, right? And so here, when we want to XOR all of nums all over again, but we keep deleting the last number in nums, right? What you can imagine is that at the very beginning, essentially, we'll have the XOR of, num1, XORed with num2, XORed with, num3, on and on and on, XOR on and on and on, XORed with, number, the nth number, right? So here we could do n minus 1, and here, num at index n, right? And so the point here is like, okay, instead of recomputing the XOR of all the numbers each time and so on, one thing that I thought of is like, okay, to delete the last character the last number every single time, what we can do is essentially XOR with the last number. So here will be num at index n. And why can we do that? Because we know that the XOR of two numbers together is equal to 0, right? And so therefore these two are the same number, so they become 0. And we know that anything XORed with 0 is that anything. So all of this XORed with this 0 becomes that all of that, so we can just get rid of that 0, right? So essentially by XORing it with the last number in nums every single time, we essentially get rid of that as part of our total XOR, right? So what I did at the very beginning is I essentially XORed all the numbers all together, and that way whenever I want to essentially delete the last element in nums to recompute the entire value, what I do is instead of recomputing the nums 0, nums 1 all the way up to the end every single time, I just XOR my result of initially all the numbers in nums XORed all together with the nums at index I, starting from the very last index inside of nums all the way up to the end in each iteration, and just keep XORing it with the value at index I, because it's like here, for example, if this is index I, when I XOR it with, you know, nums at index I here, then again, this becomes 0, which means I get the XOR of everything else and so on. So it's like effectively deleting the last character so that we can XOR it with the K every single time, right? So that's the very first thing that I thought of and why I do things in that certain way, right? Otherwise, yeah, we go through every single index, right? Because we want to do this query n times, one with all the numbers, and this second query, we do it with all the numbers except the last number nums over and over and over, and we update our XOR value each time, right? But then we want to maximize this value given a K, right? So we want to find the best case such that this answer is maximized, right? Well, take whatever this is, right? This all XORed all together will essentially just give you a sequence of zeros and ones, right? So let's just take some random sequence of zeros and ones, right? Our XOR is equal to, you know, num1, XOR num2, XOR num3, XOR dot dot dot, which in the end we'll say is equal to this, right? So just some random sequence of ones and zeros, right? It doesn't matter what it is. Well, we want to find some magical K, right? Such that when we XOR K with this value here, right, we essentially get whatever is the maximum possible value we could get. Well, what's the maximum possible value we could get? Well, it's going to be when every single bit is set, right? So when these are all ones over here, right? So we want to be able to XOR whatever the XOR of all these numbers is. Let's just say it's like some random sequence of zeros and ones so that we don't know what it is. Well, we do know, right? Because we initially computed as the XOR of all the numbers, and essentially in every single variation, we're just going to XOR with the last number nums and so on that we effectively delete and so on, so that we always have access to that XOR value every single time, right? Which is just some sequence of zeros and ones, right? What we don't know is the K. We want to find a K that will maximize our value, right? Well, first of all, we know that K must be less than 2 to the maximum bit, right? So let's say that, like, you know, maximum bit is equal to 5, right? Which means that 1, 2, 3, 4, 5, which means that we can only modify these bits in here, right? So all of these we cannot modify. So essentially, these all become zeros by default, even though it will give like some non-one answers, right? So like, for example, here it'll be a 0. It's like, oh, we didn't maximize it as much as we can. But we maximize it in terms of the constraints of this problem, because again, these are the only bits that we're allowed to modify, right? So this is like, you know, we'll make a distinction here where, you know, this is like, you know, maximum bit, right? So essentially that way it's like, you know, this is the only values that we can store. So here, like, this becomes 0, right? This becomes a 0, 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 right? So this we cannot change, right? Because we can only change up to, like, you know, maximum bits instead of whatever K value that we choose. So essentially we have a padding of zeros up in here, right? Yes. Wait, okay. Why am I confusing myself here? Because I did padding of once to essentially reverse the process, right? Oh yeah, this is in the case where this number is actually too small, right? Where it's like, let's say, yeah, if this number is too small, right? Where it's like, let's say we didn't have any of these characters, right? And then it's like, okay, then you want to pretend that here was actually a 0 and here was actually a 0, which means in your K you want this to be a 1 and you want this to be a 1. Okay. Sorry, I was confusing myself here. So there's two cases, right? Where it's like maybe K, the number K needs padding, the number XOR needs padding, and so on. You don't know, right? But here, essentially, given in a situation like this, let's just say this, we want to essentially maximize this result, right? Here we are allowed to set these bits to anything. We want them to all be set, right? 1, 1, 1, 1, 1, 1, 1. Well, we're XORing the results, right? The way XOR works is like, you know, if you have, here's an XOR table, right? If you have A here, if you have your bit X and your bit Y equals something, right? Right, and so if this is a 0 and this is a 0, then this equals to 0, right? And here, let me just do this every single time. right? So this can either be 1, and then this will be 1 and 1, and this will be a 1. So 0, XOR 0, yep. So this is a 1, this is a 1, this is a 0, right? So this is essentially the table for XOR, right? So 0 XOR 0 is equal to 0. 0 XOR 1 is equal to 1, 1 XOR 0 is equal to 1, and 1 XOR 1 is equal to 0, right? Essentially, it's 1 if and only if the two numbers are exactly different, right? It's exclusive OR, right? So usually in OR, this is also a 1 right here, right? Where it's like only if the both are false, then it's 0, otherwise it's always 1. Here in exclusive OR, it must be that 1 is exclusively true and 1 is exclusively not true, right? 1 is exclusively a 0 and the other is exclusively a 1, right? So if they're both 1s, then that's a 0. If they're both 0s, then that's a 0. Otherwise, it is a 1, right? So that's how XOR works. So essentially, if we want all of these to be 1s, let's think about it. Well, if we get a 1, we want that to be turning into a 1, right? So what 1 XOR what gives me a 1? Well, 1 XOR 0 gives me a 1. So if have a 1, want a 0, right? And now let's think. If I have a 0, I want it to become a 1, right? What XOR with 0 becomes a 1? Well, 1, right? So if have a 0, want a 1. So essentially for each 1, we want to have it XORed with a 0. And for each 0, we want to have it XORed with a 1, right? So that's why what we're going to do here is essentially reverse all the bits, right? Here we have a 1, so we're going to make this one a 0. Here we have a 0, so we're going to make this a 1. Here we have a 1, so we're going to make this a 0. Here we have a 0, so we're going to make this a 1. Here we have a 1, so we're going to make this a 0, right? And that way when we XOR them, it'll be 1, 1, 1, 1, 1, right? We're maximizing this value. So we're choosing the k that whose bits as the number will essentially be flipped of the number itself that we're XORing with the rest, right? All of this here essentially gives you a number whose binary representation is a bunch of 0s and 1s. We want to make sure that our number k essentially has those same number of 0s and 1s, but flipped. That way when we XOR it with that, we have all 1s, right? Now there's only two more possible cases, right? If you know k, if the maximum bit is here, right, and like, you know, the XOR number is huge, then all of these are essentially 0s, right? And so we got to make sure that, like, okay, we cannot modify these values inside of our k, but that's not a problem, right? Because we're just gonna, like, you know, keep modifying k from this right end. So there we go. Like, it'll always be like, you know, if you have a number like 0, it is essentially the same thing as, you know, 0b 0 0 as it is, you know, 0b 0. It's also, that's always essentially like, you know, taken care for you, right? But the part that is a little tricky, though, is imagine, you know, you have something like this here, where your maximum bit is over here, right? So these are essentially the ones that you get to play with, right? Because this is your maximum bit, and essentially here you want 1s, right? So this is why I have this padding logic in here. So let me explain this. Now let's say that the XOR number, its XOR representation only has 3 bits, right? Our maximum bit here is equal to 5, right? So here we essentially have 5 bits that we get to play with inside of our k value here, right? Everything else being all 0s, right? As our padding, right? Here these are all, you know, 0s over here, right? Because again, there's nothing. Because again, this is essentially, you know, just 0s, right? Which means that, okay, if we really only have these bits, what is the actual, you know, technical value of this value? Well, it's as if though we were adding 0s in here, right? Like if I take, you know, bin of 101, this int of 101 base 2. Well, this is the same thing as no matter how many 0s I put at the beginning, right? No matter how many 0s I put at the beginning, it's the same exact value. It's just a bunch of trailing 0s, right? Just like the same way that these trailing 0s don't matter, it doesn't matter if I put these trailing 0s in here, right? Even though it doesn't exist, because like the length of this is 3, right? And our maximum bit is 5. So essentially, I want to pretend that these are 0s, right? And what happens when we have a 0? Well, if we have a 0, what we want is a 1, right? So if our length here is actually a little bit smaller, right? Which makes things a little bit annoying. We essentially want to pretend that these are 0s, which means that we want to fixate these to be ones, right? That way it's like this is a pretend 0, this is a pretend 0, and that way it's like, you know, these become ones, right? Because this is technically like a trailing 0, which means that when we XOR it with 1, it will become a 1 exactly as we want it, right? So that's why at the beginning I figure out how much of a padding I need, which is essentially the difference between the length of this and the length of this, right? So in this case it would be 2, right? So here I need a padding of 2, and so I do it inside of my k, and my k I want to put 1s in there, right? Because these are essentially effective trailing 0s, so I want to put 1s in there to accommodate for those so that when I XOR them they also become 1s, right? So here that's why I put a padding of just a bunch of 1s at the very beginning, right? Otherwise, for the rest of the numbers here, here like 1, 0, 1, I want to flip them for each, right? So here in my code, I essentially say like, okay, negative, like num to take, right? Depending on the maximum bit and or the actual length of the values, right? Whatever index it is, like from this point onwards, I want to take each of those and I want to flip its bit, right? So here's like, okay, for bin XOR, negative num to take and so on, this is essentially like setting myself up to like read every single digit. For every single digit, what I'm going to do is I'm going to say like, okay, give me 0 if the digit is actually, or if the bit is a 1, right? Otherwise, if the bit is not a 1, then give me 1, right? So essentially all the bits are either going to be 0 or 1, so give me 0 if it's 1 or 1 if it's 0, right? That's essentially what I'm doing, right? Here is just I don't do like else if and so on because it's like I already know that they're all 1s, right? And so that is essentially what I do it, right? So for this case, it's like, you know, I go through every single index here. So here C is equal to 1, which means I'm going to get a 0, right? So I'm going to turn this into a 0. The next digit here is a 0. C is not equal to 0, so I'll go into the else clause here and I'll make it a 1, right? Here C is equal to 1, which means I will pick in this 0 and so on and da, right? And so I essentially build this as my string here, right? So I'll have this string, which again, when I XOR with this, will give me 1, 1, 1, 1, 1, 1, 1, which means I'm maximizing my value, which is absolutely excellent. So then I just take that, you know, battery representation, I slap in, you know, int of base 2 and so on to turn it into its equivalent integer, and then I append that into my answer array, right? And that's essentially what I do for every single index. And again, you know, for each a single index starting from the very last one in nums all the way up to the beginning, I keep XORing my current XOR running XOR that I have with the last element so that I can effectively like cancel it out, right? Because XOR of any element against itself is essentially 0, which doesn't affect the rest of the XOR, right? So that's why I XOR all the numbers at the very beginning, and then as I go on through my loop, I just keep XORing the last one off over and over and over and over and over until here at the very end I return and reach my answer right over here. But okay, I'll just submit this one more time. You know, I might as well keep these comments inside of my solution because, you know, why not, and so on. But yeah, it seems like we have an inefficient solution, so I'm guessing like people probably figured out how to do this part using bit manipulation instead of, you know, like strings and so on. That's just because, like, you know, I have a bit of inexperience when it comes to like bit manipulation and so on. You know, I know the basics with, like, you know, how XOR works and a bunch of these things, strictly because of my cybersecurity class that I took in college. Because like there, you know, we were like trying to bust like these algorithms and so on, so like we learned a bit of the manipulation there, but like, you know, not to a crazy extensive amount where it's like I'm able to solve these problems, at least these parts, like a lot more efficiently, right? I don't know how to, like, you know, flip all the bits very efficiently. I don't know what's the most efficient way to do this and so on, but if one of you guys know down in the comments below, I would highly appreciate if you let us know, and I will make sure to pin it for everyone to see if you do come up with a better answer. And plus I love learning from you guys, because the point of this is that I want to keep challenging myself, as well as, like, you know, I like provide like videos where it's like you can follow along too if you like. So if you do know a better way to do this, then please let me know down in the comments, and I'll make sure that I pin it so that everyone can see. But otherwise, that's pretty much it for this video. If you did find this video useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. And I hope that this solution, you know, was at least understandable in any way, shape, or form. But otherwise, again, that's pretty much it, and I'll just catch you in the next one. So until then, ciao, my friend. Bye-bye.